Yes, now I am.
If you're seeing my screen, the recipe here, the step one is to switch X and Y or swap. I'm not sure what so I actually looked into this swap, switch. When you look into the language of things, it's actually very interesting. Like, what is the correct word when you want to replace one for another? You might appreciate that. I actually spent a lot of time trying to figure out what is the right word, but you just switch positions, like X becomes Y and Y becomes X.
Mhm.
Step two is to solve for Y. And what I was showing you when you finally told me I wasn't sharing is that when you simplify, you go this direction. When you solve, you go the other. So we're going to undo subtraction by 8 first. We're going to add 8 to both sides. Okay. Get to where I can share more of my screen. There it is. So you get X plus 8 equals 2Y squared. Then you divide by 2. And you can, at any time, you can move from one side to the other, kind of mirror it, if you
Mhm.
will. And then the last step here is to take a square root of both sides. When you take a square root, it's plus or minus.
Right.
Okay, now yes, the answer is there in your assignment. Is there anything that I did here that is unclear now that you're able to see my screen? Anything you couldn't do on your own, I guess?
No, I don't. Well, no, I don't think so.
Okay.
I see what you did.
Yes. So the it's the same every time. Like, we're going to do a couple of problems here that are, really identical here to
Yeah.
this. You switch X and Y, and then you solve for Y. And we don't need to get into why this works. We just need to know that this does work. So let's look at number 5, which is really similar to the first one. And we're going to start by switching X and Y. So to solve for Y, we're going to subtract 1 from both sides to undo addition by 1. And then next, we're going to undo multiplication by 16 by dividing by 16 on both sides. And then this is my preference, is to really get Y on the left. That's just the convention we've used forever. And then you take a square root of both sides. I guess I didn't show that very well in the last problem, but you take a square root of both sides. When you do that, it's plus or minus. So Y equals plus or minus the square root of X minus 1 over 16. Now we look at the answer space and see if any of those are there. And the answer is it is not there. Let me look, boy. Okay, so none of the answers match this. If you look real close, you'll see that they're all kind of slightly different. All
Yeah.
of this is under the square root. So there's this property of square roots, which is if you have an A over a B, it becomes the square root of A over the square root of B. So in
Mhm.
your problem, it becomes plus or minus square root of X minus 1 over the square root of 16. The square root of 16 is a nice number. It's friendly. It is 4. Now, do you see that answer in the answer space?
I'm sorry, my computer's acting up right now.
No problem. No problem. Let me snip it in and see if you can just pick it off from the list here.
So it'd be the last one, right?
Yes.
Usually I print out the homework sheet and I work on it that way, but I don't have my printer at the moment, so it's a little bit more difficult. I'm doing it all
Yeah.
online.
Right. For the first one that we did, do you want to just tell me verbally what you chose as the answer, just to make sure you got the right?
Yes, I pushed A.
Hey, great. Okay.
Yes, thank you. Okay.
All right. So the next question here we'll look at is 3. And I will snip in the answers because we may need them at some point. Oops, that's not the right place to snip that. All right. So which equation can be simplified to find the inverse of y equals x squared minus 7? For the moment, let's try not to, and I know it's hard to do, but it's like ignore the answer space and let's just do what I've suggested, which is you switch x and y. And then I want you to now look at the answers and do any of these look exactly, it has to be exact, like this line here.
Yes. See.
Yes.
Okay. I didn't really want it to get super far into it.
No, I would, that's what I was gonna have us do another line and then look, another line, then look. So this is very, so let's go, sorry, I should have done 9 next because 9 is kind of more straightforward. Let's go to 7. 9's got a little wrinkle to it, a little oddity. All right, so let me just verify that this is how it is written in the correct typesetting.
Yes.
Okay, fantastic. So even though it's not the same as the last ones, it's the same recipe, it's the same procedure. And so you literally just move the positions there. So it's 2y minus 2 squared equals 8, 7 plus x. A problem we have not seen yet is like, let's just say there was more than one x. You would still make each x into a y. And similarly, if there were more than one y, you would change those into x's. You change the variables. Okay, so to solve this for y, which is our goal here, I should even write that, solve for y, we're going to first divide both sides by 2. So that gives you y minus 2 squared equals 4 parentheses 7 plus x. Let me look at the answer space just to make sure that we are going down the right path. Yes, I believe we are. Okay. Okay, so how do you undo a square?
You square root.
Square root both sides, y minus 2 squared, plus or minus square root 4, 7 plus x. You only square root the non-squared side. You only plus or minus the non-squared side. And again, let's not worry about y, let's just like follow the procedure here. Typically it's on the right. So this becomes y minus 2 equals plus or minus square root 4 times 7 plus x. Okay, and then the last step is to add 2 to both sides. And my convention, my choice is to put that number you're adding or subtracting, depending on the problem, right in front. So it becomes y equals 2 plus or minus the square root of 4 parentheses 7 plus x. Can only imagine how hard this would be if you couldn't see the screen and you did just have to go off of, auditory. That would be really tough.
I couldn't do that. I'd be like, wait a minute, what did you say?
Yeah. Pictures really express a lot more than words so often. So when I look at the answers here, I can see which one it is, but I'm not sure you would see it. They do a simplification, or they actually distribute this to both terms, this 4 inside
Mhm.
there, and that's what gets you to the final answer there. 28 plus 4x, like that.
Okay.
All right. So do you have these up in front of you? Do you have 8 and 9 in front of you?
Yes.
I want you to pick one or the other. And I know we usually wait till the end, but I'd like you to just try either 8 or 9. Doesn't matter to me, but you pick. They're the same as the ones we've been doing. They're just different operations.
Key.
And what I'd like you to just spend a few minutes working out one of the other, and then I'll jump in and help if needed. But which one do you think you'll do?
I'm doing 9.
Okay. All right. So I'll check back in like 2 minutes or 3 minutes.
Okay.
So what I'm going to do is just grab the question and start working it out. And you're welcome to look and just confirm your answer at the end. All right. So I do have an answer here. How does this compare to what you have? And there are some variations of this, like you might have put the 100 first, or
So I put the 100 first, and it was minus X.
yes, and that works. Fantastic. Okay, so let's see. Looks like letter A will do it for you on that one.
Mhm.
All right, so let me grab question 8. All right, what is the first step here? What do we always do first in the
Oh,
inverse?
switch the y and the x.
Yes, just making sure you haven't fallen asleep on me, because I know like this is not interesting. They're because it's so procedural. There's only so many times you can do the same thing over and over again until you're like, all right, I got it. Like what's the purpose of this in life? Have you ever heard this sort of aside here? And I don't even know if this is a true story, but they asked, like, I think it was like 80 people, and they showed up at a work site. And they said, we're going to pay you $10 an hour, and they said, we're going to dig a hole. So they dig a hole. Then they go to lunch, and then the afternoon they fill the hole back in. I don't know if it's true story or not, but there is a. So then the next day, like 40 people show up. This time they pay them $20 an hour, but sadly, they dig a hole, and then the afternoon they fill it back up again.
That's crazy.
Okay. And again, I don't know if this is true or not, but the way the story goes is this continued until there was no one left. Even though they kept paying them more and more money, fewer and fewer people started showing up. And this is completely unrelated to math, but the point is like, if you don't have purpose, if you don't know why you're doing something, you lose value. And that's kind of what's going on here. It's like, we've done now, I don't know, this is fifth or sixth problem, but like, you need to know why you're doing this. And maybe it's just to get through this class, but we're kind of losing steam on like the effectiveness of this, because it's like, okay, we switch x and y, we solve for y, and we get an answer, and we're done. So all right, let's keep chugging along here. We got to solve for y. We're going to subtract 1/2 from both sides of the equation. Let me look at the answer space again and see if they actually do combine things. It looks like they do. So 4 is really 4/1, and that's really 8/2. So when you combine it with that, you get 7/2. You get 5x plus 7/2 equals y plus 3 squared. And as you know, when you undo a square, you take a square root of both sides. All right, and so on the right, you get this y plus 3, and then you get this 5x plus 7/2. And then finally, you subtract 3 from both sides. So you have y equals -3 plus or minus the square root of 5x plus 7/2.
Sorry,
That
catching up with
yeah, no
Okay.
problem here. Yeah, this does look like it matches up well with one of the given answers there.
So that would be D.
Yes.
Okay.
All right, so the next question we'll do is number 2.
Mhm.
And then I'll do some visual stuff here afterwards. Because it will help with the inverse. It'll give you some context, I guess. Maybe I should have done that sooner, because I know you're very, you like to see things, and so do I. I really do here. So it says, here's a function, yay. What can you do to find the domain? So the domain is the input values, like what inputs are good, okay?
Mhm.
And to answer this, the way that I show this is that it's the part under the root. The part under the root has to be greater than or equal to 0, okay?
Okay.
but I see that answer here. I see that answer here. But here's what I also see. I also see this one and this one, which kind of jive better with what this thing is referring to, but they're also
Mhm.
the same, which bothers me as well. So I don't know what to tell you to do. I I I want you to decide on your own how to answer this, but the this is what I tell students. I'm going to suggest the answers probably be because there's duplicates there,
Yeah, okay.
but I'm not sure.
Interesting.
All right. Okay, so let me new share Desmos. Okay, and I'm going to graph some stuff here for you so you can see.
So last time when we did Decimos, it helped me a lot when I went and did more problems like the ones we did. It helped a lot.
Fantastic, fantastic. Visual tools like this are great. Okay, so the next thing I'm going to graph here, I'm graphing this. Do you see this green function here on the
Yeah,
left? And you see this line right here going through the origin.
yes.
All right. And then y equals this function. Now, I want you to tell me if the green is when mirrored over the purple becomes the black. Like, do you see that visually?
Yeah, I would agree with that.
Like as it gets further away here, it gets further away here.
Yeah.
Okay. So these are inverses of each other.
Okay, yeah.
Okay, believe it or not. And the reason they're inverses is because they are mirrored over this line right here.
Uh-huh.
Okay. So let's try another one here. Let's say we go y equals square root of x. Okay. And then watch this. I'm not going to graph it yet. I gotta do a little thing here. Okay. Are those mirrors of each other? Is the green a mirror of the black?
I think so.
You would agree with that, right?
Would.
So the visual meaning of the inverse is that it has to be a mirror over this line y equals x.
Right.
And there are other ways to express it, but that is one good one. I'm trying to think of some better functions here that we could use to do this. So let's try this one here. Let's go with y equals x cubed. Okay. And then y equals x to the 1/3 power. Do those also look like mirrors?
Yes.
Yes. So like what I mean by that is it's always the same distance apart.
Yeah.
And so on. So let me go back to the other screen. And there are other types of questions that you would actually do a lot better at if you were given something like this. So one type of problem is, and you create this y equals x line each time. Oops, wow, that was really bad. Can we actually get here? So it's this one. Okay, so let me just actually copy this in case we want to do another one here. So let's say I gave you a curve that came straight in like this.
Mm-hmm.
Do you see how this would be the inverse?
Yes.
Because it bends in, has to bend out there. They're always the same direction.
Oh, yeah.
Okay. If I have something that approaches like that, the other side I get from going this way. Do you see that?
Yes.
Okay. So some problems actually ask you to draw the inverse of it. Now we have plenty of time to get to all of your assignment tonight,
Mm,
but I wanted you to see the visual representation. So if I go back to this original problem right here,
mhm.
and if we graph 2x squared minus 8, and we graph this one right here, they will
Right.
be inverses of each other.
Oh, okay. Yeah.
Okay.
Yeah.
And that would be like one way to try to do it, is to just graph them and see like, well, which ones mirror over that line that Matthew was talking about.
Right.
Okay. So let's jump back to the actual assignment. I'll see if I can do some more visual stuff at the end, depending on the time that we have left here. So four is like 2. Let me go grab this. All right, so I mentioned that, my preference here when you're finding the domain with a root is you set the part under the root greater than or equal to 0, and you solve x. So you're going to subtract 6 from both sides. X is greater than or equal to -6. And that, that's it for that. There's nothing more to do.
Answer. Which question number 4?
All right. So what I would like to do is I'm going to graph this. So I'll just graph it. So we're going to work on 6,
Mhm.
and I'm going to switch screens to the grapher. And where is it? Where is it? There it is. What is going on? Okay. So I'm going to graph y equals square root of x plus 4. As a reminder, if you use Desmos, this keyboard down here, it's got your functions, like your square root. Well, your square root's actually here, but if you need some of this other stuff, you can also just Google. You can say, how do I enter whatever into Desmos? You'll get a million answers on this here. So, all right. So if I zoom out, and if I don't know where to zoom out, I hit the home button.
Mhm.
Okay. You always go home. This is the graph of the square root of x.
Okay.
Okay. The domain is the inputs. So like, do you see if I put 0 in for x, and you actually can just grab the curve here. See how it gives me a number?
Yes.
Okay. And if I actually just go along here, that I'm holding my mouse down. If you have a tablet or something, use your finger to just trace it.
Mhm.
Do you see how all these x values are producing a y value? Like when x is
Yes.
10.01, y is that? Your domain is the x values. Okay. So your
Mhm.
x's are everything starting at 0 and going to the right, because all of these x values I can put in and get a number out.
Uh-huh. Sorry.
Okay.
Yeah.
But if I give you a negative number, like, and here's another way to look at it. Let's say x is 1. Okay. Do you see how it intersects the graph?
Mhm.
Okay. But what if x is -1? Does it intersect the graph?
No, it doesn't.
No. So this is not part of the domain.
Mhm.
Okay. So while we can do the same thing we did in the last problem, which is set the part underneath the root greater than or equal to 0, visually, the domain is like the x values that are good, that are allowed, that are
Right.
friendly. You can think of domain as like a curfew or something. This is okay, this is not okay.
Yeah.
Okay, so let me jump back to the other screen. And so again, the answer here maybe is clear, but you set this part under the root greater than or equal to 0. There's nothing to do now because it's already solved, and you have your answer. Now you might say, okay, Matthew, that's great, but the answer isn't X. I'm not seeing that there. Another way of writing this, which is it's very odd the way they're doing it, is a compound inequality. So 0 less than or equal to x, and then infinity's over here. The less than sign has to go with infinity. It can't be less than or equal to.
Oh, okay.
Okay. Is the last one just the 10? Tell me 1, 2, 3.
Okay, we did 7. I'm trying to figure out if we did 7 or not.
We did 7, yes. I can
Okay.
scroll up to it.
Yep, that would make it only 10. And I found more work for 7. I guess didn't put it on the computer.
No problem. So the last one is, it's already graphed, so it's really similar to the last one, because that graph is there. So let me snip that in. We can work on it together. All right. So the domain, again, they're looking for the domain. It's kind of that same problem here where, like, if you, this is 1, by the way, if I draw a vertical line, see how I hit it, and like well, so 1 is good, right? And if I go with 2, 2 is good, and 3 is good, and you probably see a pattern here, right?
Yeah.
Okay, well, what isn't good? Well, 0 is good, but what about -1?
-1 does not work.
It's not good. So it very simplistically, we can say, well, any number to the right, 0 and to the right, is good. So which one of these says 0 and bigger or larger than 0?
Last one.
Yes.
Okay.
All right, so we do have some time left if you would like. We could also stop here, but it's up to you. You are the customer. You get to decide how we use the time. It's not like flight school or flying hours where you're like desperate for more, sadly. Oh, by the way, I meant to ask you this earlier. You can, if you've done any flying or any practice and all that, I'm sure they tell you, like, this is why you need to know this when you're doing it, I hope, or you get that. And I'm sorry that this math that you're doing isn't more like that. But those are the kinds of questions that I like to answer for students, which is like, why do I need to know this? Why is this important? And we didn't do much today that falls into that category. So I really apologize for that. But most of the cool stuff we do in real life, when you ask that question, you should get a really solid answer. You should be like, this is why you need to know what this knob does, or what this mechanism is for. It really is important. So
no, it's been hard with the math program we've been using. It's just like, they're like, so you already know this, and I'm like, okay, so maybe at one point I did know this, but I don't remember it, so like, go over it again. And it doesn't ever like go over it, and I'm like, I don't want to like repeat everything, but I wish they didn't just assume so much, like I know so much. I'm like,
yeah, so like what you want is you want this nice staircase of learning, and probably what it feels like is there's the step that you're trying to get up.
that's how it feels.
And the ramp looks like this instead of a nice little ramp up like that.
Yeah. And I'm like, why? So that's been difficult. I'm like, they're like, yeah, you already know this. I'm like, okay. So they're reviewing stuff. I'm like, I don't know what we're reviewing, so hopefully don't build too much on it. And then they do. I'm like,
now in another class, let's just say it's an English class or history class or something like that. If you're interested in it, I would bet you go out and you read or you look for stuff on it, or you find the other information that you need to fill in the gaps. Is that a fair thing to say that you
Yeah,
might
that would
be
be a
doing?
fair thing to say.
Yeah, and it's because you're excited about it. And
Mhm.
and the math just isn't doing it for you. It's not interesting yet. You're not doing anything kind of like really novel or exciting, but those same skills are what could help you here. If you had the time, if you wanted to, it's really no different than those other classes. You just got to find, because I know you're a really good student in those and doing really well in those other classes. You just got to figure out what works and apply it to math if you can some
Yeah,
way.
it's, I guess math used to be really easy at one point. I guess like a long time ago that would be, and it made sense. Everything was working. It was probably past the point that we were just doing times and division over and over and over and over again. I could do it. And then they go and they're like, here's pre-algebra and here's algebra. I'm like panicking.
Yeah,
So then I sink. I'm like,
but you are capable. From what I understood, your dad said you're taking some college equivalent classes. I mean, that's fantastic, and it's very noteworthy that you can do that. So I know you have the ability to figure this out, and I'm happy to keep helping along the way, but don't feel discouraged. Don't feel like you can't do this. One of the things I put up on social media one time is there's only results or outcomes. We as humans say, oh, I passed or I failed, but that's us. It's really just results. So like, if you're ever struggling, I don't know if you've ever been to a KFC, but like Colonel Sanders, he tried to over 1,000 times to get someone to put his recipe in their kitchen, and they kept telling him no. And he kept trying, and he eventually got to where, he became this owner of this huge franchise. Um, and it's really important to remember that they're just results. Whether
mhm.
whether you passed or failed is like the projection we put on stuff. So when you're working through this stuff, yes, you're getting a grade, but there's more to it, and you're more than capable of doing this stuff. So
Yeah, it just has to remember that. So,
they're only results. All right, what else can we do with the time tonight?
um,
What else would be helpful to you, or should we
I
stop here?
don't want to do like the same problems over and over again because obviously that's what we did all night. It wasn't like they gave us two problems of one, and I'm like, wait a
Mhm.
minute, we need to work on that more. I'm just trying to figure out another thing to do.
So let's look at some problems that might be upcoming.
Okay.
I'll give you a preview um, of something you might see in the future. Let's see, it's 2x minus 3 over 4x plus 7. Okay.
Mm-hmm.
And it'll say to determine the inverse. Okay. Now the real first step here that we didn't have to do in the previous problem is you replace f of x with y. And it seems like a minor thing, but you don't work with f of x. You just, I mean, it's extra writing for one thing, but you want x and y. Okay. And then what I call step 2 is where you turn x into y and y into x. And this was one of the examples I was talking about where you actually have to do it for more than one letter. Oops, 4. So I'm sure you know a dentist out there. Been to the dentist, know a dentist. The dentist take what's called a dental admissions test. And this question as is always on this exam, believe it or not. So all the dentists out there in the world, they had to solve this problem at one time. And it's very, very recipe based. Like from here, it's like, well, what do I do? Because there's y in 2 places. So the answer is you cross multiply. And you might see this in your next section. That's why I'm choosing it to do. So it's x times 4y plus 7 equals 1 times 2y minus 3. And sometimes things get worse or messier before they get better. You actually need to distribute this x to both terms. So it's 4xy plus 7x equals 2y minus 3. And then from here, you want to group the y terms. And what that means in a better language is to move the y's left and the x's right. So in terms of math operations, you're going to subtract 2y from both sides, and you're going to subtract 7x from both sides.
Oh, okay.
So it becomes 4xy minus 2y equals minus 7x minus 3. And the order doesn't matter. You could choose minus 3 minus 7x or minus 7x minus 3. It really doesn't matter. Okay. The next part here is to factor out y.
Mhm.
So on the left, it becomes 4x minus 2 equals minus 7x minus 3. And then the last step is to divide both sides by the 4x minus 2. So notice, and I think this is kind of interesting, notice the form of the inverse is very similar to the form of the original function.
Yes, it's very close to it.
It's very close. This happens over and over again. That's why they like these problems in standardized testing. Okay, so if you understood that, I'm going to give you one much more simplistic. Could you please find the inverse of this one here, please? Y equals 1 over x. You don't have to, it's not f of x, it's just already y. Could you find the inverse of this?
It's y over x.
So did you switch x and y?
Oh, that was it.
You gotta switch x and y.
Yes. Mm.
Now you have to solve for y, and it's similar to the last one in that you have to diagonally multiply or cross multiply. Some instructors call this a butterfly. So you get x times y equals 1,
Mm-hmm.
and then you divide both sides by x. So what do you notice about the function and its inverse?
That's pretty much
Here's what we started with.
it's the same.
They're the same. That's interesting. So let me share a graph with you quickly. So if you're seeing my screen, you're seeing the Desmos again.
Yes.
Do you see the what 1 over x is this graph right here, and there's this black line is the y equals x.
Yes.
Follow that? Now watch this. Here's the top half. Here's the bottom half. Sorry, let me do that one more time. I didn't realize I was going to do that. Okay, so here is the top half, and there's the mirrored part. Do you see it?
Yes, I do. Okay, that's weird. I didn't think it'd be different.
So there are a few functions that are the same, and they are inverses of each other, where they're exactly the same. And this is one of them. This one's kind of the really well-known one. The other one is y equals x. Y equals x, x equals y. See how it's right on the line? It's an inverse of itself.
Right.
Okay, it's not as kind of interesting, but it is. So, but the 1 over x is kind of that one that kind of really cool. It's also got some other neat properties of it that are useful in other, physics, engineering stuff. But But for your purpose, like I would just try to remember that it's a mirror image over this line right here.
Okay. Yeah, I see that.
All right. Well, we got through it. You did great. I'll send you the notes and the screen recording here shortly. And I guess we'll probably do another lesson later in the week. So look forward to helping you then. And
Okay, I do have one question.
sure, go ahead.
For like before like state testing and stuff, is it possible to get like tutoring for that,
Of
or
course, of course.
how does that work for that? Like, do I have to provide questions? Or are you able to do it? Like, I'm just
One or
curious.
one or the other. So
Okay.
what I first need to know the state, and then we'd want to go right to their website and see if they have any practice materials. And if they don't, I'll just either provide some of my own, or you can get a book and send me pictures and we can work through it.
Okay. Yeah, I was
If
just curious because state testing is one of those things where it always like freaks me out. No
yes,
matter how much anything, like if I did good at the year or anything like that, it just always freaks me out because I'm worried that they're gonna have problems that we didn't go through.
yeah. And now math anxiety is a real thing. It don't it just anticipate that's how you're going to feel. But more you prepare, the more you're gonna have some better chances to succeed on it. But yeah, if you're ready, we can absolutely start covering some of those concepts and
Yeah,
and,
I
and work
will
through it.
see if maybe we can like do like maybe one problem each time we meet or something like
Yes,
that, or at least to like just work on it a little bit at a
I
time.
think I think that would be great.
Okay.
All right,
Thank
Emma.
you.
Thank you so much for scheduling. I'll send you the notes here shortly, and I'll see you next
Okay.
time.
Bye.
Have a great
Have a
night.
good
Bye now.
night.